We are going to cover some basic theory before we are moving to the question. In the week 2, we discuss about the crystal structures. If you can remember, in the week 1 we discuss about the atoms and how they behave. Like, for example, how many protons are there, how many electrons are there, where are they in the periodic table, atomic number, and also we discuss about the how to write the electron configurations. Do you remember that? Electron configurations for atoms, and also we discuss about writing the electron configurations for ions. We discuss about bond energy, and also we discuss about different types of bonds, ionic, covalent, metallic. Do you remember those? So in this topic 2, we discuss about how the atoms stay in space. So they can stay in a arranged way, or else they can stay like so. This non-crystalline, that means this one, if you look at this, it doesn't have a repeating unit, but crystalline means we have a repeating unit. It is arranged in a way that there is a repeating unit. So when you look at ceramics and metals, they have a repeating unit. So we call that the unit cell. So we are discussing about it. So when you look at crystal structures, we need to know the crystalline material is one in which the atoms are situated in a repeated or periodic array over large atomic distances. So you can see this one, we have a repeating cell. Crystal structure of materials is the manner in which atoms, ions, or molecules are spirally arranged. That is a three-dimensional array of points consisting of atoms positioned in different spaces. So you can see this is a lattice, and these are the lattice points, and this whole thing we call the unit cell. So you can see this is a cube. So FCC and BCC are cubes. Do you remember that? So we discuss about these three cubic structures. Simple cube. Which one is this? What is this one?
Body-centered cube.
Yes, body-centered cube. We use BCC for that. And why we call it BCC? Because you can see, apart from the corner atoms, we have a whole atom inside the body of the cube, isn't it? So we call that body-centered cube. What is this one?
Face-centered cube.
Face-centered cube, as the name says, you can see a face atom in each face. So there are 6 faces. In all of those faces, we have a centered atom at the face. So we have, these are the 3 basic cubes, BC simple cube, BCC, and FCC. So when we look at these cubes, we need to know these unit cells. We need to know the coordination number. What do we mean by the coordination number?
Is it the number of diagonals or atoms touching?
When you consider a centered atom, how many atoms are touching that? For example, here if you look at this centered atom, 8 atoms are touching this. So the coordination number for BCC is 8. Do you remember that? We did it in the lecture.
8 atoms are touching.
How many atoms are touching this one?
Isn't there only 2 atoms in the whole cube?
That's the number of atoms in the cube, but if you coordination number is how many number of atoms are touching a centered atom. So when you 8 atoms are touching that middle atom. Am I right? And how about this one? So we already discussed what are the coordination numbers for FCC and simple cube as well. If you look at FCC, what was the coordination number? You have to think the three-dimensional way. So this atom, face atom, is touched by these 4 and 4 face atoms, and at the other side another 4 face atoms. So it is 12. So coordination number for this one is 12. So likewise, we discussed those things in the lecture. Close pack direction means what?
The radiuses touching.
Yes, along which direction the atoms are touching. So for example, here, face-centered cube, the atoms are touched along the diagonal. Am I right? Is that right? So along the diagonal length is 4 times the radius. Do you agree with that? And how about this one? In a simple cube, which direction is the close packed direction? Where the atoms are touching. Any edge will be a close packed direction. Am I right? There is no spaces between atoms. So here edge is 2r, isn't it? Am I right? Yeah.
Can I ask what's the coordination number for the simple cube?
Simple cube, if you consider this one, 1, 2, 3, 4, 2, 3, 4, 6. This is again 12, isn't it?
What would you say that is?
If you consider, let me check, okay? We'll go to, if you consider this one, 1, 2, 3, no. This one is not touching, sorry. So that one is, diagonals are not touching. So it will be this, and 2 like this, and here like that, isn't it? So that will be 4, 5, 6. This should be 6. Am I right? So do you see the touching, so this one is touching by only this. So this is touched by this and this, not the diagonal directions, isn't it? So the coordination number is 6 for the simple cube, coordination number is 8 for the BCC, and the coordination number 12 for FCC. Make sense? Okay, at close packed direction for BCC is which direction?
Through the center.
Through the center from one edge to the other edge, isn't it? So starting from here and going to here, so that will be your close packed direction, and along the close packed direction again the distance is 4 times the radius. Is that right? Yeah. And so coordination, close packed direction is fine. So number of atoms per unit cell. How many number of atoms in a simple cube? 1. Because why? How the 1 came? 1/8 times 8. Yes. So how many atoms, total atoms in a BCC? 2. How many total atoms in FCC? 1 corner atoms. When you add all the corner atoms together, it is 1. And there are faces, 6 faces. Am I right?
Yes, I'm pretty sure it was 6.
6 faces in a cube. You have 6 faces. 1 face is a half atom. So 6 faces means how many atoms? 3 and the 1. So the total number of atoms in a FCC is 4. Am I right? So FCC 4 atoms, BCC 2 atoms, and simple cube just 1 atom. If you add all the pieces together, that will be the number of atoms in a unit cell. Volume of atoms means what? Volume of atoms. Atom is a sphere. Am I right?
Yeah.
Atom is a sphere. So a volume of a sphere is this. Am I right? And if you know the number of atoms, we know the number of atoms. In a simple cube it is 1, in a BCC it is 2, and in FCC it is 4, isn't it? So if we know the number of atoms, we can just put the number of, if we know whether it is simple cube, BCC or FCC, we can just put the number of atoms here and we can find the volume of solid. Volume of solids means the volume of atoms. Do you agree with that? Okay. So what do we mean by volume of this one also? We are done. So volume of unit cells means what? Volume of the unit cell is what? They all are cubes. Am I right? So volume of a cube is a cube. If you know one side is A, that will be a cube, isn't it? However, we don't know this A, but radius of any element is known. Magnesium radius, aluminium radius, we know the radius of any element. So we should know the relationship between A and R. Am I right? So A and R relationship is what? If you consider simple cube, A and R, A is this, R is, so A is 2R. Am I right? For simple cube, A is 2R. Do you agree with that? How about this one? We'll do at the end. We have a question. Okay, so this is a bit long to find the relationship. We'll find, we already did it in the lecture. However, what is the relationship here? What is the A and R?
equal 4r over square root 2.
Yes, how did you get it? So you, yes, so this one is 4r, diagonal is 4r, isn't it? Because 4 radius, so this length is a, this length is a, so you can apply the Pythagoras theorem and you can say a squared plus a squared is equals to 4r squared, isn't it? Am I right? So that will be 2a squared is equals to 4r squared, so a is equals to 4r over root 2. So that will be the relationship between a and r for FCC. And for BCC, we did it in the lecture. However, we will do it at the end because we have a question regarding this one and we will be able to solve it using that. Are we good? Why?
Just remembering something.
Okay. So volume of unit cell is okay. Volume of atoms. Atomic packing factor means what? Atomic packing factor. The meaning of atomic packing factor is volume of atoms in the unit cell divided by the total volume. That means Vs divided by Vc gives you the atomic packing factor. Am I right? So atomic packing factor says how closely, how densely the unit cell is packed. So face-centered cube is the most densely packed one. So this is 74% or 0.74 is the atomic packing factor. If you find the atomic packing factor for the BCC, that will be 0.68. So you can find the atomic packing factor. I don't remember this one. So we don't have much simple cubes because simple cubes elements stay in a simple cube is very rare because they are not densely packed. So most elements are either BCC or FCC and we don't have many with the simple cube. So are we good with this theory up to here? Any question? No questions? So you will get 0.5 marks for attending, not just sitting, okay? So you have to actively participate. Are we good?
Yeah.
Then we discuss about the directions and the planes. So we should know how to identify, give the address or give the name for a direction or a plane. So we call them the Miller indices. How do we recognize? So these ones have X, Y, Z directions and we are going to find, we will do some questions. Okay, so we have to find the Miller index of a direction and we should know how to find the Miller index of a plane. So Miller index of a direction comes inside square brackets, three numbers here. First one related to the X direction, second one related to the Y, and the third one related to the Z direction. And there are no commas, so if you see something like this, this is a direction. How do we know this is a direction? Because we have square brackets and three numbers represent, they are related to the three directions. Are we good? And planes again, plane look like this. So we should know how to write the Miller index of a plane. So again, we have Miller index for a plane with three numbers. First one related to the X direction, second related to the Y, and third related to the Z. And there are no commas in between the numbers. So planes have parentheses and directions have square brackets. Are we good? Are we good?
So is this notation important that the plane is written in direction is square parenthesis?
Square brackets and the other one is parenthesis, the normal
brackets.
brackets. This is a must, yes. Okay, now we need to know how to write the coordinates of a point. So how do we write the coordinate of a point? So you have X direction, Y direction and Z direction like this. So if you want to find the coordinates of A, how do we find the coordinates of A? A is here. So what is the procedure? From the origin, you go only along X, Y and Z and reach the point and you find out how long you need to go along the X, how long you need to go along the Y and how long you need to go along the Z. So to reach the A, you only have to go one. They are unit cells. So one side is 1. Okay, so you only need to go one along the X and you're reaching A. Am I right?
Yeah.
So this point coordinates will be 1, 0, 0. Am I right? So how about B? B should be what? 1, 0, 1. How about C?
Is B, isn't it 0, 1, 0?
Yes, yes. 0, 1, 0. And the next one is
0,
C.
0, 1.
0, 0, 1. How about J? J is halfway, okay? Halfway, halfway. So tell me how
Half, 0.
J half, 0 and a half. Yes. So are we all good with finding the coordinates of a point? Yes.
Yeah, Miss, I wanted to see the grades and the directions, which parentheses to use.
Directions are square brackets.
Directions are square brackets.
And the planes are parentheses or the normal brackets like this. So these are planes and this one is.
APF equal Vs over Vc.
Yes. Vs is the volume of solids. That means the volume of the atoms. Vc means the volume of the cube. Okay. Are we good? Any question? Are we good with the points? You don't get questions with points, but without knowing the points, you can't do the directions and the planes. Which one? B? B?
Yeah.
Just you go along the Y.
Yeah.
So 0, you need to go along the X. You don't have to go along the C. You only have to go along the Y. So X is 0, Z is 0, just one, Y is 1. Only Y direction, yes. So if you want to go to, like, for example, if you want to go to this place, how do you write it? How do we write for this place?
Which one?
This one here. You need to go 1 along the X and half along the Y, isn't it? So that will be 1, 1, half and a 0. You don't have to go along the Z. If you go somewhere here, then it will become 1 along the X, half along the Y and half along the Z. So you are only going along X, Y and Z directions to reach a point. You can't go from here to here, like, you have to go only along X, Y and Z to find that point. Are we good? All good? Okay. I will do a few questions with the directions. These are your questions in the tutorial are for hexagon, but you can't do hexagon if you don't understand this. So that's why I'm doing few questions, and then we'll move to the tutorial questions. Okay. So to writing writing directions. First thing is you need to find the coordinates. So end coordinates. Where is the end point?
1, 1, 1.
End point is 1, 1, 1. Do you all agree with that?
Yeah.
And what is the start point? 0, 0, 0. Okay, then what you do is you minus n minus the start. So this will be 1, 1, 1. Am I right? Then you need to check whether you have any fractions. If you have fractions, they are indices. You can't keep fractions. So you have to times all three numbers by a number to get rid of the fractions. For example, if you have a half, if you times everything by 2, then your denominator will vanish. So you have to get rid of the denominator. They have to be indices, whole numbers. You can't keep it in fractions, yes. So in this one, we don't have that issue. So we will put these numbers in a square bracket. So this we call the Miller index of that particular direction. Are we good?
Yeah.
Okay, so can you do me the second one? What is the end point?
1, 1, 1.
End is here. 1, 1, 1, yes. What is the start point?
0, 1, 0.
0, 1, 0. Are we good? Just need to go 1 here to reach the start point. End point is C, and you already told me end point. 1 along the X, 1 along the Y, 1 along the C. You are reaching the end point. So 1, 1, 1 is the end point, and 0, 1, 0 is the start point. What's that? For some points, you don't have to go along the X at all. See the start point? Start point is you don't have to go along the X or Z. You just go along the Y and you are reaching the point. So 0 is X, X is 0, Z is 0 as well, only Y is 1. Okay. So start minus the end, we have 1, 0, 1. So this will be your plane. Am I right? Now when the plane is given, sorry, it's the direction, sorry, my brackets are wrong. Am I right? For a direction, we always put the square brackets. So how do we draw this? First thing, when this one is given, you know this is a direction. How do you know this is a direction? Because it's square brackets. So you have 0, 1, 0. This is your end. When the direction, the Miller index is given for a direction, you start from the origin. Okay, so this, you consider this as your end point. Y, x is 0, z is 0, y is 1. So this is the point, isn't it? So you start from the origin and you draw a line with an arrow, and this will be your direction. So when the Miller index is given to you, you should know how to draw the direction, and when the direction is given to you, you should know how to write the Miller index. Are we good? How can we write this one?
From the origin to that corner.
Which corner is that? 1, 1, 1 is which corner?
The opposite corner.
This corner, right? Along the x you go 1, along the y you go 1, along the z you go 1. So this is your end point. So start to end, this will be your Miller index. Agree? Agree? Okay, so I have some more questions for you. Okay, do this for me. I'll give you a few minutes. First do these ones. The direction is given to you. You have to draw you have to write it. So this is starting here, half. Okay, so this is starting at half.
These questions were out there. In the
You don't. I found it in the internet.
You record this section?
Yes, I'm recording this. Drawing a cube is really easy. If you want to draw a cube, how do you draw it? You just draw a square and another square. Then you do this. So that will give you a cube. Okay? 2 squares will give you a cube. If you want to draw a cube, just one square, another square like this, this will give you the cube. But normally in papers, we will give you the cube. So you just have to mark the x, y, z directions, and you have to do it like, we will give you this. Okay, let's do. Have you done this? Okay, so what is the end point here? 0, 0, 1. Am I right? End is 0, 0, 1. Do you have the same?
Yes.
And what is start? Start is 0, 0, half, and a 0. Am I right? Is that right or wrong? Start n minus the start is what? Is this right? So can we keep it like this? What we need to do? Multiply by 2. So this will be 0, negative 1, and 2. So when we put this in the brackets, we have to put 0, 1, and 2. Negatives we put at the top. Okay, so we put square brackets. Do we put commas in between the numbers? No commas in between the numbers. Negatives should go at the top of the number. We can't keep fractions. So this will be the Miller index of this particular direction. Any question? No questions? Next one, what is the end point? What is the end point? 0, 1, 1? 0, 0, 1, 1. Yes. Start is what?
Half 0, 0.
Half 0, 0. So this will be 1, 1 and a negative half. So this will be negative 1, 2, 2. Am I right? Is that right? Next one, what is the end point? 1, 1, 1, isn't it? This is your end point. It is 1, 1, 1. And what is the start point? 1/3, 1/2, and 0. So when you 1/3, when you minus n minus start will be 1/2 and a 2/3. Yes. So how do you get rid of the denominator this time? Multiply by 6. So this will be 4, 3, and 6. Am I right? Is that right? Any question? No questions. Okay. Can you draw these ones now? How do you draw these ones? These ones. Whenever you have a number more than 2, more than 1, that means it is not fitting inside the unit cell. Unit cell is one side is 1, isn't it? So you have to divide by the largest number there to make all the numbers less than 1. So we can fit it inside the unit cell. So which number we should take as the denominator? So you are dividing everything by 2. So this will become half, 1 and 0. So this will fit inside the unit cell. Agreed? So where is the half? Half is along the x. Half along the x. 1 along the y. So that point will be here, isn't it? And this will be your, from the origin towards that point will be your direction. Am I right? Second one, again we need to make all the numbers less than 1. So we divide everything by 2. So 1 along the x, half along the y. So that point is here. So if you draw a line from the origin to this point, that will give you the direction of this one, isn't it? Next one is 1, 0 and a half. So 1 along the x, 0 along the y, half along the z. So this will be this point. Agree? So when the Miller index is given, you can draw it, and when the direction is given, you can find the Miller index. Are we good? Any question regarding directions?
Can you repeat this one?
Which one? You mean this? So you have 2, 0, 1. 2, this is the end point. Am I right? But you starting is always from the origin. So this will give you the end point. But this end point is not fit inside the unit cell. 2 is more than the unit cell. So twice. So we need to get all the numbers less than 1 so that we can fit this inside the unit cell. So what we need to do for that? You find the largest number here, which is 2. So you divide all the numbers by the largest number. So you have 2 divided by 2, 0 divided by 2, and 1 divided by 2. So you have 1, 0 and a half. So along the x you need to go 1. So that is this one. And along the y you don't have to go. Along the z you need to go halfway. So that is this one. So you are ending up here. So this is your end point. Start is always origin. So origin to the end point, you just draw a line and arrow. Are we good? Any other questions? Now let's look at planes. So in the planes, first thing that you need to check is whether the plane is going through the origin. If the plane is going through the origin, then we have to either shift the origin or either shift the plane. Okay, so in these two questions, these two, the origin is like, plane is not cutting the origin. So we don't have to think about it. In the plane, what you need to do is you find the intercepts, x-intercept, y-intercept, and the z-intercept. You extend the plane and see whether this plane is cutting these 3 axes. Is this plane cutting x-axis? This one here. Is it cutting the x-axis? where it is cutting the x-axis at 1. So x is cutting at 1. Why is y cutting at 1 as well? Is it cutting the z-axis? If you extend the plane, it will go parallel to z but never cut. So you can see one side is parallel to z. So if you have this parallel to z, even though if you extend, it will never intersect. So this will be never intersect, infinite. Is that right? So what we did, we find the intercepts of x, y and z. Then we take the reciprocal of this. So 1 over 1, 1 over 1. We didn't do this step in the direction. So we are doing this only for the plane. So 1 over infinite. So 1 over 1 is 1, 1 and this one is 0. Am I right? Then again we need to check whether we have any fractions. If we have any fractions, we need to get rid of the fractions. If we don't have fractions, that's fine. And we put them in parentheses. So this will give you the Miller index of this plane. Are we good? Any question? Can you do the second one, please? What do we get for the second one?
1, 0, 0.
X, Y, and Z. X is cutting at where? You all agree with that? X is cutting at 1. Y, is it cutting at Y? Never cutting. So infinite. And Z is infinite as well. So you can see parallel to, one side is parallel to Y and the other side is parallel to Z. So they are not cutting at all. So this will be 1 over, so this will be 1 over infinity is 0, 1 over infinity is 0. So this will be your, you have to take the reciprocal of that. Am I right? When you take the reciprocal, that will be 1, 0, 0. Are we good? Now, how do you do this? When the Miller index is given to you, we should know how to draw the plane as well. So this will give you where it is intercepting. So it is intercepting y at 1. So that is this point, isn't it? And 0, 1, 0 means if you take the reciprocal, infinite, 1 and infinite. It will never cut the x or never cuts the z. So what you need to do is, it is only cutting at 1, so that is this point, and you draw parallel line to x and z where you have infinite, and this will give you the plane. Make sense? Can you draw the second one, please? 0, 0, 1.
Square.
Okay, so I'll give you some time for the others as well. So it's only cutting z. So this, if you take the reciprocal, infinite, infinite and 1. Never cuts x, never cuts y, but it is cutting the z at 1. So z at 1 is this. And parallel to x and y, parallel to x and y. So this will be this plane. Agree? Are we good? Any question? Yeah, I want you to do these 6 questions, please. I'll give you some time for you to think. So if this is intercepting x at 1, am I right? C at 1 as well. How about y? It's parallel to y, am I right? It's parallel to y, isn't it? Is it parallel to y? So if one edge is parallel to y, so that means it is never cutting, it's never cuts the y-axis.
It's infinite, miss?
It's infinite. So if you take the reciprocal, 1 over 1, 1 over infinite and 1 over 1. So 1, 0, 1 and normal brackets. Are we good? So how about the next one? What's the problem here? I told you, first thing that you need to look at is whether the plane cutting the origin or not. It is. So what we can do, we can either shift the plane, or we can either shift the origin. So you can bring the origin to somewhere like, you can bring the origin to here, or else any point, you can bring it anywhere. So if you do that, what will happen? Where are the x, y and z? X is intercepting at -1. Agree? So this is our origin now, isn't it? X is intercepting at back of this, isn't it? So that is -1. Y is intercepting at 1. C intercept, if you extend, you can't say Z, if you extend this one, sorry, C is here. If you extend this plane here, it will cut the Z axis, don't you think? Imagine, like, visualize it. It will cut somewhere, isn't it, in Z? So if you extend this one, the plane is slanted, it's not parallel to Z. So that will cut somewhere in the negative side, isn't it? So the numbers, you should get the numbers. So if this one is given the numbers, you can't say this is infinite. There should be something negative here. Okay, this one I just copied from the internet, so we don't have numbers. But I want you to understand that if the plane is not parallel to Z, it will cut somewhere. When you extend it, it will cut the Z axis somewhere. Do you understand that? Same with this one. See, we have to shift the origin. You can shift the origin anywhere. Like, you can bring the origin to here, like this. But again, Z, X, Y, and Z. Z is cutting at -1. Y is cutting at, if you extend this one, it will cut the Y, and also it will cut the Z, X as well, because the plane doesn't have parallel lines to X or Y. So that means it is cutting somewhere. You agree with that?
So you move that plane that way?
Not the plane. I move the origin. Yes. Origin can move in any direction. Planes can move parallel any direction. Like the parallel planes have the same properties because they are repeating unit cells. So parallel paths will have the same properties. Does that make sense? Okay, now can you draw these planes, please? Can you draw these planes? I'll give you a few more minutes. What you need to do first?
Move one to the x-axis.
You need to get rid of, so this one, 1, 1, 0. How do you know this is a plane? Looking at the brackets. So you have parentheses, that means they're asking you to draw a plane, not a direction. So 1, x cutting at 1, y cutting at 1 as well. Am I right? So Z is not cutting, so your plane is parallel to Z at these 2 points. So this will be your plane. Agree? So this is 1 x, this is y is equals to 1. So you mark the 2 points and you connect the 2 points. The other edges will be parallel to Z. Why is that? This one is infinite, never cuts the Z. Is it clear? Clear or not? How about the next one? 1, 1, 1. If you divide by 2, it is x is 1, y is 1, z is 1. So when you connect the 3 points, that will be a plane like this. If you have infinite, you draw parallel lines all the time. So you see, you drew a parallel line to z. So you have a parallel line here and a parallel line here to z, because these 2 points are given. These 2 points are given. So you can connect the 2 points and the other will be parallel to z. Next one, 1/2 and a 1. So x is 1, y is half, and c is 1. So that will be like this. Make sense? That's it, yes. Only thing is, when you have infinite, you need to think that it is parallel. The rest is the same. So you can find a lot of questions. If you Google search, you can find cube questions. But in your tutorial, you only have hexagon. But I hope now you are, yes. What's that? Yes, I will put it in in Panapto. Okay. Okay, so are we good? That's all from the summarizing part, and now we are going to move to the tutorial. Any question? No questions. Okay, so this is your question number 1 in the tutorial. So they have given us four hexagonal closed packs, and they have given us directions. So we are going to write the directions. So this theory I didn't cover in the lecture, so I'm going to explain you the theory. So when we consider hexagonal closed pack, we have 4 directions. So one in along the plane. So you can see A1, A2, and A3 in the same plane, and the z is upward in the vertical direction. So when we write the plane, Miller index of the plane, we have the square brackets, and we have here 4 numbers. So 4 numbers are related to A1, A2, A3, and Z. Are we good? Does that make sense? Okay, so in the procedure, what we need to do here is I will show you the steps that we need to follow. A1, A2, A3, and Z. Yes. So here, vector represented or to pass through origin. So always you get the origin here, starting from the origin. Now you need to find out to reach the end point. You do the same thing. So your end point, when you consider the end point, x, y, z you did in the cube. You do the same thing here. You need to consider A1, A2, A3, and C. So at the beginning, what we do is we ignore the A3. Okay, so we don't think about the A3. We find out the end point coordinates considering A1, A2, and C. So this is our end. Am I right? To reach the end, I have to go 1 along the A1. Am I right? 1 along the A1 and half along the A2 and half along the Z. Do you agree with that? Is that right? That's how I can... We are ignoring A3. I told you we ignore the A3 at the beginning. So we go along A1, A2, and C. Same thing that you have done for the cube. So you can reach the end point just by going 1 along the A1, half along the A2, and half along the Z.
So what is our point? What are we trying to find?
You are going to write the Miller index of this this one here. Do you see that there is an arrow, green arrow, line and an arrow? So that's the direction. This is the direction. Do you see that?
Okay, and what would you say is half? For the Z?
So this is halfway along. This line is your parallel to A2, isn't it? And it is halfway. This is half.
Okay.
And also this is your parallel line for Z. Again,
So
it is halfway.
the Z axis there?
It's not touching. It's like,
It
X.
crosses the Z axis there?
It's not crossing. It's like, this is not planes. These are directions. So you have to find the end point of a direction.
Okay.
So end point of a, how did you do here? How did you do here? So when I say this is X, this is Y, and this is Z, and if I ask you to find this point, coordinates of the point, how did you find the coordinates of the point?
1, 1, 1.
How did you find it? You went 1 along the X, 1 along the Y, and 1 along the Z.
Yes.
So you do the same thing here.
I'm a bit confused from the plane.
Yes, so don't get confused. So how do we reach the end point? Only going along A1, A2, and C.
Okay.
You have to go 1 along the A1, half along the A2, half along the Z, and you are reaching the end. Is that right? And start is always 0, and n minus the start will be half, and 1. Then what you need to do is adjust the smallest integer value. So how do you adjust it? You have to times by 2. So this is 2, 1, and a 1. Then what we need to do is we need to find this one as well. So we need to make them to these ones we call U dash, V dash, and W dash. These are not the ones we need. We need them as four numbers, 4 integers, U, V, T, and W. To find these ones, you are using these equations. Okay, so using these equations, we have to find U, V, T, and W. So U is what? U is equals to half times 2 times U dash is 2 in our case u prime is this, so 2 minus v is 1. So if you put this one, if you find this, that will be 1. Am I right? So your u is 1. Are we okay? So do you understand how I got this u? From the u dash, you all okay to find u dash. After finding u dash, are we able to u dash, v dash and w dash? Are you okay to find the u here? Because our Miller index for the direction should have u, v, t and w inside square brackets. So is it clear or not?
So that's W dash and on the one.
Yes. This one is w dash, yes. Can you find me v, t and w as well in the same way? You have this equation. So just find me v, t and w. What is v? V is 1 over 3. 2 times v is 1 minus u is 2. So your v is 0. Agree? V becomes 0. Am I right? Yes. So what is t? T is negative u plus v, not u dash plus v dash, u plus v. So u plus v negative is negative 1. Am I right? T is negative 1. Do you get the same? W is w dash. This is 1. So
You already found the u?
yes. We found all of them. We found these four, u, v, t and w. Do you anyone have any issues with finding u, v, t and w? How do we put them in the brackets now? You follow the same things that I have told you before. You put square brackets, 1, 0, negative is at the top of the number, and this will be our answer. This is this line here. Are we good? Any question?
Get t minus 1.
Yes. Any question? No questions? Okay, then I have, you can do the other three by yourself.
We get equations.
Yes, these four equations will be given to you. Yes. Okay, can I move on to the next question? Okay. Okay, this one. Can you try this, please?
Directions and stuff.
Okay. So, do you understand that this direction is A1?
Yes.
Do you understand this direction is A2? Forget about the Z, okay? So if you want to reach this point, if you want to go to this point, how you are standing here. So how do you walk to this point? You only can go along the A1 and A2.
Yeah.
So how do you reach that, go to that point? So you have to go like this. Do you agree? You have to go like this and go like this.
And 1 A2.
Yes. So A1 should be half and A2 should be 1. And A3 we don't do, and Z you don't have to go along the Z, is 0, isn't it? Yeah, that's it. Now you have to get rid of the denominators. You have to make it to numbers. So 1 and a 2 and a 0. So this will be your U dash, V dash and W dash. I want you to find the U, V, T and W. What is U, V, T and W? What's U? 0, yes. V 1, T -1, W 0. So when you put them in the bracket 0, 1, -1 and a 0 like this. Are we good? So that's the 4 questions we have for directions. Yes. You ignore the A3 at the beginning, but you are writing the A3. See, you got something for A3 at the end. We are finding this one. The T is for the A3, so that you have it. So we have all 4. Okay. So any question regarding the directions? We are going to move to planes in the hexagon. Are we good? No questions? Okay, so this is your question number 2. I want you to try this, and after you try by yourself, I will do it here. So I'll give you a few minutes for you to try. So you ignore A3, am I right? You don't have to think about A3. So you need to think about A1, A2 and Z. So how do you reach the end point? How do you reach the end point? You have to go. Do you have to go along the A1? How do you reach the end point? You can reach it if you go -1 along the A2. That's it. You don't have to go along the A1 or Z. Am I right? So this will be 0, -1 and 0. Is that right? Start is 0. So if n minus 0 will be the same thing. Is that right? Did you get this or not? Did you get 0, -1 and 0? So where did you go wrong? Did you find where you went wrong or not? So you only just by going from the origin, you just have to go -1 along the A2, opposite direction along the A2, then you're reaching the end point. Am I right? So that will be just this one, isn't it? So this is your U dash, this is your V dash, and this is your W dash. So can you find me U, V, T, and W, please? What is your U? Just you have the equations here at the top of the slide. What is U? This is D, isn't it? This is D. What did you get? U is what? Are you sure? So how do you find U? 1/3, 2 times U minus 1. So this is 1. So yes, 1/3 is right. Yes, 1/3. Okay, how about V? -2/3. We all get this. How about T? T is negative U plus V, isn't it? So that will be 1/3. T is 1/3, is that right? And how about W? W is W dash, which is 0. Am I right? So we have this 1/3, -2/3, 1/3 and 0. Can we keep like this? Can we keep fractions? No. What we need to do? Times by 3. So we have 1, -2, 1 and 0. Is that right? So how do you write them? We can't keep negative in front of a number. We have to put it at the top. So this will be the direction. Are we good? Is this right? We're good? Any question? How do you do this one? I gave you a few minutes. So you need to consider A1, A2. We don't consider the A3 at the beginning. So how do you reach the end? This is half, okay? Think. So I think you now understand why I did the cubes first. This one is a bit complicated than cubes. Without knowing how you work on the cube, it's hard for you to do the hexagon. Am I right? So now you should be fine with the hexagon because we have done we anyway did some questions on using the cubes in the lecture, but I don't know whether you were paying attention. So that's why I wanted to refresh that memory. Now you should be able to do the hexagon. Okay, so if you tell me what you get, and I'll check whether it is right. You say it is just half. If you are starting from here, if you go halfway, is it that you are here? Okay, so you can't reach that point. Yeah, you don't think about A3. You don't have A3. You can only go along A1, A2, and C. So how you reach the end point?
I only got half for the Z's. The others are 0.
Others are 0, half. So then you go this. You are ending here. Is this the point?
No, but like I put half for Z, but I haven't done A3.
Okay, so
the
do.
others I put 0.
Okay.
I don't know what they are.
Okay. Yeah. So
Zero. For A1 and A2 I've put 0.
Then you ending here.
I don't know, miss. I thought I'm not getting it.
Okay. So you have to think. So to reach this point, So this point is here, isn't it?
Yeah.
To get to that point, you can go. If you go, A1 is negative here, so it's going like this. Do you understand? So you go this here like this and like this. Is that path correct? So this will be A1 is -1. If you go -1 along the A1 and -1 along the A2 and half along the Z, don't you reach this point? Do you reach that point? You go -1 along the A1, -1 along the A2 and half along the... Because A2 is this way.
Yes.
So -A2 is this way. So you are going parallel. See, these two are parallel. Am I right?
Is that a cube you can work with? Yeah?
Which?
Am I mistaken? Like, is there a cube?
No, it is a hexagon. That's why I told. Cube is easy. Now you are working in a
Can you
hexagon.
play around with it like a cube there? Like, I don't know, I see like a cube there.
No,
Can you
it's
play
not a
around
cube.
with it?
It's...
Okay. I'm maybe visualizing a cube there. I thought you've went by like and you've sort of made it into a cube, and that's how you've played around with it. I visualize a cube there for some reason. Maybe just me.
Okay, so when you do that, do you understand we are going in the parallel direction to A2? These two are parallel.
Yeah, no, I understand.
Okay. So do you all agree with this? -1 and half. At the back, boys, do you understand this? So to reach this end point, I have to go -1 along the A1. So I'm drawing these points. See, -1 along the A1, -1 along the A2, and half along the C, and I'm reaching the end. Do you agree with that? Now what we need to do? We need to get rid of the half. So how do we get rid of the half? Times. So -2, and a 1. So this will be your U dash, V dash, and the W dash. And now I want you to find the U, V, T, and W, please. What do you get for U, V, T, and W? What is U? When you find, let me know. Okay, U is what? -2, 2/3. You can get rid of the T, 3. Yes, you can get rid of the 3. Yes. So V is what? V is what? Put the numbers in the equation.
Give it a go at home, because I'm not comfortable with it yet.
Same, -2/3. T. No. T is adding these two. No, not adding. Yes, I think G. Yes. So you're adding these two. Yes. So 4/2. That means 4/3. Yes. W is 1. Not minus, because you have a negative in front. Yes. So now you have -2/3, -2/3, 4/3, and 1. So we have to times by 3. So we have -2, -2, 4, and 3. So when we put in the put it like this. Am I right? Is this right? Do you understand this? Yeah. Yes.
Definitely this is recorded?
Yes, recording, yes.
It's on session or Tuesday session?
This one.
This one. Okay. Do you find them both on the views?
No, I didn't record the Tuesday. Yes. Okay, can I move to the next question? Okay, so now we are going to do planes. So I will do one and I will explain you the steps. Then you should be able to do the other planes. Okay. So we'll take the first one. So do you remember what we did with the cubes? We found where the plane is intercepting the axes. Am I right? So here again, when you consider the intersection of this plane in the A1, A2, and Z, is this plane intercepting A1 or parallel to A1? The whole plane is parallel to A1 and A2. Do you agree with that? Even though you extend the plane and the direction, the axes, that will never cut. They are parallel to each other. Do you agree with that? The plane never cuts the A1 and A2. So they are infinite and infinite. Am I right? Z is cutting at halfway, isn't it? So then you read the intercept of the plane in the axes. So first thing is you need to check whether the plane is cutting the origin. I forgotten to tell you that. So this plane is not cutting the origin, so we are fine to work as it is. Then read the intercept of the planes with axes in terms of unit cell dimensions A and C. So that's this one. So take reciprocal. So always the difference between planes and the directions, you need to remember, you don't take the reciprocal in the directions, but you need to consider the reciprocal, the flipping upside down. You need to do that for the plane. So you take the reciprocal, so that will be 1 over infinite, 1 over infinite, and 2 over 1. So 0, 0, 2. Are we good? Then reduce the smallest integer. So they are integer values enclosed in parentheses. Okay, so this will be h, k, and l. So we need to have another one here for I3, which is, we call that the I. I can be found using this equation. When you add k and h together, you get the I. So in this case, I will be 0. So you can write this one as 0, 0, 0, 2, and you have to put it as which brackets? Which brackets that you need to put? Normal brackets for planes. Am I right? So that will be normal brackets. So this, do we put commas? No commas. So this will be my answer. Any question? Okay. So if we have, yes, if we have denominators, if we have fractions, here if you have fractions, you need to make it to numbers. Even after you are finding this one, if you have fractions, 4, if you make 3 to 4, when you make 3 to 4 again, if you have fractions, you can't keep fractions, you have to have integers. Okay, we'll do some questions with fractions. Which one?
C.
Which C?
The C, how did you calculate the C?
You mean I?
C.
This is I. This is I. Yes, I is this equation here. H plus K. That means these two addition. That is LL. Yes. HKIL.
These were both 0. This is infinity. You find the reciprocal of 0.
Reciprocal of 0 is infinite. That's why we are shifting if this is going through the origin, what will happen? Intercept will be 0. Then you have to take the reciprocal, which is 1 over 0, 1 over 0, 1 over 0. Then you get infinite, infinite, infinite. So this is not valid. That's why whenever the plane is cutting the origin, we are shifting the plane or either shifting the origin, because otherwise we are ending up with infinite. So we can't have infinite, we should have numbers. So that's why we are shifting it. Make sense? So we never get infinite as a number here, okay? Because we have to shift the plane, or else we have to shift the origin. Are we good? Can I move to the next question? Okay, so how do we do this? You can shift the plane or either shift the origin. So it's easy to shift the plane here. So you can shift the plane to front or to back. It's up to you. Both are right. So now you have a plane like this, where it is intercepting A1, A2, and Z. A1 is, let's take the front plane. So where it is intercepting? 1. 1, never intercept, never intercept. If you take the back plane, what is happening? A1 is what? If you consider this one, A1 is cutting at -1, isn't it? So you can either take this or this. It doesn't matter. Two different planes, but have same properties. Okay, so then what is the next step? Taking the reciprocal. Am I right? So let's take the front plane. So 1 over 1, 1 over infinite, 1 over infinite. So this will be 1, 0, 0. And this one is 1. Am I right? The missing number is 1. You are just adding these to the front two numbers. And your plane will be this. Agree? Plane is 1, 0, 1, 0. Is that right?
H plus K.
H plus K is this. H plus K is 1.
Yeah, but there's a minus outside.
Yes, yes. Is it a minus?
Yeah.
Yes,
My-
yes.
my edge was straight outside my-
Yes, you have a minus. Yes, that's right. So this is a negative. Yeah, that's right. Yes, it is a negative. Negative h plus k.
And you have to write it on the top.
Yes, you have to write it at the top. So we are writing it at the top. Are we good? Any question? No questions? Okay, we'll move to the next one. Can you do this one, please? I'll give you a few minutes. We have another long question because we have two more planes and then we have to move to the last question. It will take a little bit time. Can you quickly do this, please? A1, A2 and C. Where it is cutting A1? Minus 1. A2? A2 minus 1. Where it is cutting here? It is 1. C is cutting at? It's a slanted one. So you see it is cutting at 1. Isn't it? So that will be, even though when you take the reciprocal, you still get negative 1, 1 and a 1. So this will be, your third number will be 0. Am I right? 0. So that will be negative 1, 1, 0 and a 1. Are we good? Any question? Are we good? Last one. A1, where it is cutting A1. What's that? A1, if you where it is cutting here, isn't it? It's negative half. Agree? A2, 1. Z is half. See, it's a slanted one. You need to imagine three-dimensionally. So it's cutting here. It's given actually. That's halfway, the Z. Then you take the reciprocal. And your middle, this I is what? Negative. Negative 2 plus 1, which is equals to 1. So your numbers will be 2, 1, 1 and 2, the normal brackets. Am I right?
The reciprocal isn't that 1, 2, same 1.
Z is 1. No, it's not 1. Z is half. Yes.
The reciprocal of, sorry, of negative half is, I have to take the reciprocal.
You are taking the reciprocal, you are not getting rid of the denominator.
Yes.
Okay, so you need to remember that. For the planes, you are not getting rid of the denominator, you are flipping it. Are we good? There are two more questions actually. Can we move on? Any question? No questions, then let's move on. Okay, the third question is derive the planar density expression for the HCP 1110 plane. This is the 1110 plane. So it is parallel to A1, A2, A3 and cutting Z at 1. So plan in terms of the atomic radius R. Compute the planar density value. Planar density means if you consider a plane like this, number of atoms in that plane divided by the area of the plane give you the planar density. So that's the definition of the planar density. So how do we find the planar density for this plane? Let's move to the other slide. Okay, so this is your plane. So planar density means number of atoms in that plane. So how many atoms you can find? Whole atoms. If you count the pieces and make them to a single atom, how many atoms in that plane? How many? How many? 1/3 of atom. Here you have one atom. This is 1/3. Am I right? 1/3 times 6 atoms are there. 1/3. So that will be 2, altogether 3 atoms. And what is the area of this one in terms of the radius? How do we find the area of this hexagon? One side is 2 times the radius. Do you agree with that? Because this is half, like 2r. Isn't it? Am I right? And this is 2r as well. And we have triangles. If you consider these triangles, half times 2r times h is the area of one triangle, isn't it? Am I right? So how many triangles we have? We have 6 triangles. What is h? If you consider h is something like this. This is r and this is 2r and this is h. So you can write the Pythagoras theorem and find the h. So h squared plus r squared is equals to 2r squared. So you can find h. And you can substitute h here and you can find the area. Can you find me the area? Is it clear or not? So we have, yes. Anything can be in the exam. Equations will be given to you, yes. You don't have to remember any equation, yes. So how do you understand? The number of atoms are 3. And the area of the hexagon we have to find in terms of the radius. Isn't it? So there are 6 triangles. If you consider one triangle here, one side of the triangle is 2r. Isn't it? So if you consider the height as h, you can write the area of a triangle as half times 2r times h. Isn't it? Is that the way you write a triangle? Area of a triangle. The h you can find considering this relationship. It's a right angle triangle. So you can write the Pythagoras theorem and you can find h. So h is what? H is √3 times r. Isn't it? If you solve this, h is √3 times r. 4r squared minus 1 is 3. So √3. So you can substitute it here. Then you have half times 2r times h is √3r times 6. Is that right? Two will cancel out. Then you have √3 times 6r squared will be your that's your area. So you have to put that area here. Number of atoms 3. So this will be √3 times 6r squared. So this will be 1 over 2 √3r squared. Is that right? That will be your planar density. Agree? Any question? That's not materials. This is just maths. Finding areas. Finding area of a hexagon is not materials. It's your maths. Is that right? So you guys already know it. Any question? So our planar density will be this. So they're asking us to get an equation for the planar density. Let me check whether we have the same solutions. Yes, we are right. Okay, now the next part of the question. I'm doing a bit fast because otherwise we won't be able to finish. So this is what we found. And they are saying for magnesium, the radius of magnesium you can find if you search it. So they're asking us to put this as the R. Radius of magnesium is this. So you can put this as the R and you can find the planar density of magnesium. Can you find me this one, please? So that will be 1 over 2 root 3, 0.16 squared atoms per nanometer squared. So you get something here. So do you get 11.28 times, yes, 11 atoms per nanometer squared. Do you get this? Did you get 11.28? Okay. Did you understand the method? Any question? Didn't understand?
I need a bit more long.
Okay. Okay, so I'll move to the last question. If you can ask, if you can try by yourself, and if you get stuck, you can ask me. Okay, you can email me, or else you can ask during the lecture. Okay, we have a BCC crystal. With the atomic radius of this. So atomic radius is given to us. Atomic weight also given to us. Avogadro number also given to us, and asking us to calculate the edge length of a unit cell. So BCC, edge length of a unit cell, how do we find it? And the volume of the unit cell, number of equivalent atoms in the unit cell, volume of atoms in the unit cell, atomic packing factor, calculates the theoretical density. I will show you the equation for this, but all of these ones we already discussed at the very beginning of the tutorial, didn't we? So how do we do this? So BCC is this. So edge length A. What is the relationship with? So here you said that A is equals to 2 times the radius. And you know this one as well. During the lecture we discussed, we found the relationship between A and R. How did we do that? Do you remember? From here to here it is 4R. Am I right? And if you consider this and this is a right angle triangle. Do you agree with that? And this is your A. Am I right? And what is this? This length is what? That length will be, this is A and this is A. So that length should be what? A squared plus A squared square root of it, which is equals to root 2A. So this length is root 2A. Do you agree with that? So in this right angle triangle, one side is A, the other side is root 2A, and the diagonal is 4R. So this, when you apply the Pythagoras theorem, it should be like that. Am I right? So we are looking at this triangle here. This is 4R, this is A, and this is root 2R, root 2A. So you can say A squared plus 2A squared is equals to 4R squared. So 3A squared is equals to 4R squared. So A is equals to 4R over root 3. So this is the relationship between A and R for BCC. Using that, we can do the rest of the question. So the radius is given to us as what was the radius? Here 0.1363. So A we found, it is 4R over root 3. So 4 times 0.1363 over root 3 will be your edge length. So that was the question number 1, part 1 of the question. So if you put the numbers in the equation, you should get 0.31478 nanometers. You do it by yourself at home, okay? So do you understand the procedure? So we found the relationship between A and R. This never changed for BCC. It's the same relationship. If you don't know how to get it, at least you can remember it. So you put the R value here and you find the A. That will be your first question. R value given in the question. It's in the question. I can't go back to the question, and because I'm recording in the PowerPoint. If I go back, that will get deleted. Yes. So this will be, that is your first question, and that part 1 of the question. The next one, they're asking you to find the volume. So how do you find the volume of the cube? If you know one side of the cube, volume of the cube is equals to A cube. So if you cube this 0.31478, cubed it, you get the volume of the cubes in nanometer cubes. Do you agree with that? Just cubing this number, you will get the volume of the cube. If you do that, you get 0.03119 nanometer cubes. Are we good? So finding the edge length and finding the volume, I hope you are okay with that. In the BCC, how many number of atoms in a BCC? Total number of atoms in a BCC.
BCC 2.
2. So if you want to find, so they're asking us to find the theoretical density. So the number of atoms will be 2. This will be your atomic weight. It is given in our question. If you go to the question, atomic yes, so it's given to us 95.94. So this is 95.94 grams per mole. This one we found, that is this, and Avogadro number is given to us. Can't we find the rho density? Density is just substituting these values, you can find the density. Are we good? Any question? Are we all okay? Only part that we haven't done is the atomic packing factor. Atomic packing factor is A solid divided by A cube. A solid is, we know that, number of atoms times 4 over 3 pi r cube divided by the VC will give you the atomic packing factor. R is given to us. N is 2 for BCC. R is given to us as 0.1363. Are we okay with this question? You may need to do it again by yourself, and if you have any questions, ask, okay? I had to rush because I can stay if you can stay. I can stay. Yes, this is a tutorial question. Yes. Tutorial. The equation is in the lecture. The question is in your tutorial. Yes. You have only 4 questions, but yeah, at the end, the last question. Yes. Okay, so yeah, if you want to stay and discuss, we can discuss. I can stay. Otherwise, if you have finished, we can wind up the class.
I'll see if anybody. Are you having fun?
If everyone is leaving, yes. If you want to stay and discuss anything, or if you want to go through this.
About the theory, I'm worried about the theory. I can't find any of the theory. The theory, you're telling me 20 multiple choice questions.
Yes.
I want to know how to study more, Do we find these informations in the lecture?
Yes, yes.
Word for word?
Word for, yes. If I ask, like, for example, a question can be...
you said about the covalent bonding and metallic bonding. Which one is standard?
We did. It's in the first lecture. Lecture 1.
Okay. I couldn't find any, but yeah, so it's word for word sort of thing. And 20 of these questions are
very easy ones. Like, for example, if I ask you which crystal structure having middle atom at the face, ECC, FCC, HCP, or simple Q.
VCC.
So you at the face, not inside the body.
No, I think you said inside the body. At the face, FCC.
FCC. So is it? You already know that?
Yeah.
So you have those kind of questions.
What would
Basic
be
question.
What would be the weakest bonding?
Yes. So
Covalent.
I'm not getting this.
weakest bonds are the secondary bonds. We discuss about it. Secondary bonds are hydrogen bonds and van der Waals attractions. So the covalent, metallic, and ionic are stronger. Secondary bonds are not stronger. So if I have given you metallic, ionic, covalent, and hydrogen bonds, then you have to mark the weakest bond is as the hydrogen bond, because it's a secondary bond, or else van der Waals. Yes. So they are very easy. We have discussed them.
20 questions will be multiple choice.
Yes. It's
20.
Yes.
Okay, and 4
or 5. Okay, I don't remember.
They're big marks. Like they're more marks.
2 marks. They are also not very long questions. They are also simple, small. Because you have only 45 minutes. So you have 20 multiple choice questions and 4 or 5. I don't remember written questions. They are also like, if you do all the tutorials, if you go through the lecture notes, you will be fine. Yes. Yeah.